Hydrogen. Hydrogen is the first element in the periodic table and it occurs in nature as H2. Okay, elements in the periodic table are arranged according to their electronic configuration, and hydrogen is having the electronic configuration is 1s1. But it resembles to both group 1, that is alkali metals, and group 17, that is halogens. Now let us discuss what are the resemblances with alkali metals. Resemblance with alkali metals. Okay, and hydrogen, the electronic configuration is 1s1 and its atomic number is 1. Okay, so first resemblance with alkali metal, only one electron in the outermost shell in hydrogen and alkali metal. Only one electron in the outermost shell. Okay, second point. So both hydrogen and group 1 metals have the tendency to form unipositive ions. That is, both are having the tendency to liberate this one electron and form unipositive ions. Okay, both hydrogen and alkali metals form unipositive ions. Next, both hydrogen and group 1 have the tendency to form oxides. They have the tendency to form oxides, halides and sulfides. Example, oxides Na2O. Similarly, hydrogen form H2O, then halides HCl, okay, and sodium form NaCl, then sulfides H2S, and sodium form Na2S. Okay, so both alkali metals and hydrogen have the tendency to form oxides, halides and sulfides. Okay, these are the resemblances. Okay, there is some differences between these two. Which are they? Let us discuss one by one. So differences between hydrogen and group 1 metals or group alkali metals. Okay, first point, ionization energy of hydrogen is very high. Okay, in the case of hydrogen, ionization energy is found to be 1312 kilojoule mole inverse. Okay, in the case of lithium, delta H or ionization energy is found to be 520 kilojoule mole inverse. Okay, so there is a large difference between these two. Okay, this ionization is energy of hydrogen is very small, very high is due to it's very small in size compared to lithium. Okay, this is the first difference. Next, in the case of H plus ion, the size is very small. It is about 1.5 into 10 raised to minus 3 pm. The size of H plus ion is very small. So it always associated with other atoms, but not in the case of alkali metals. Okay, these are the differences. Okay, now next, what are the resemblances between halogens and hydrogen atom? Let us discuss one by one. Resemblances with halogens. First point, halogens, the electronic configuration is outer electronic configuration 1s2, ns2, np5. Okay, so these halogens have the tendency to gain electrons. Okay, similarly in the case of hydrogen, ns1. So it is also having the tendency to gain electron. This is the first resemblance. Okay. Next, what about ionization energy or delta H? Delta H of halogens and hydrogen are nearly same order. That is, in the case of hydrogen, delta H of hydrogen is found to be 1312 kilojoule mole inverse. Okay. In the case of fluorine, it is found to be 1680 kilojoule mole inverse. So, almost near. Okay, this is the second resemblance. Now, third one, hydrogen is diatomic. So, it excesses H2. Similarly, halogens also diatomic. That is example F2Cl2, etc. Okay, next, fourth point, halogens and hydrogen form compounds with carbon. That is, hydrogen form hydrides with carbon. Similarly, halogen form halides with carbon. Okay, hydrogen form hydrides with carbon and halogens form halides with carbon. Example CH4 and CCl4. Okay, CH4 and CCl4. These are the resemblances. Now, let us discuss some of the differences between hydrogen and halogens. Differences. First point, halogens are highly reactive when compared to hydrogen, or hydrogen is less reactive than halogens. Next, second point, electron affinity or ionization energy of hydrogen is less than halogens. Okay, these are the differences. Okay, due to these properties, the hydrogen is having a unique behavior. Okay, hydrogen is having a unique behavior. So, due to this, hydrogen is placed separately in the periodic table. Okay.